Navigator website.
Shui was talking about this guy right here. This is the example in folder 10, what is it, 15, 16, 17, 18, I think? He want to know about this class here. Why we didn't talk about this?
Yeah.
Well, my main thing is we were talking about polymorphism, so I just wanted to get to the traffic light, how we build a traffic light using polymorphism. But this here, it's a interface, a GUI interface, how can I say, graphical user interface class where we just create like a stage and a title. We're going to talk more about this when we cover this chapter. This chapter was chapter 4, and then I think it's chapter 12. Yes, chapter 4 and chapter 12. We skipped, but we are going to get back to this understanding. But basically, all I'm doing here is creating a utility graphical user interface where I set up the stage. I set up the window, okay? I set up based on the width and the height the user is going to pass me. So the user is going to send me the height, the width, and the title, and an object for the stage.
Stage is the pop-up box.
Stage is your window. So hold on, let me go back in here. Where's our traffic light.java? Right here. See here? I'm calling that class. Do you see that? I'm calling that class. I say here, create a new object called GC of type graphics context and call the function setup graphics. So when I go in here, here's my setup graphics. And it creates that, whatever, the stage, it creates a stage, which is your box, your whole window. And it has a title. What is the title? The title is, what did I call? Traffic light. Okay? And then what is the height and the width? I pass down here too as well. I pass 700 and 400 for the height and the width.
This is the box height. It's not the height of traffic light, right? But it is the window.
The window where the traffic light is set. Remember, we have the big window and the traffic light is there. Remember? Is that big screen, correct. The size of the actual traffic light is defined over here.
What is the size, square size?
The square size, that's 80 right here. Is remember, we are drawing 3 squares and putting them together. Do you remember that?
Size is area?
Well, let me think. 80, I think is the side of the square.
Side, so
yeah,
will be
it's the side, like it's like 80, the size of the line. The size of the line.
20 times 4?
Probably. Or maybe it's just 80 on each side.
80 of each side? Oh, okay.
Okay, and then 300, 100 is where it's going to be placed on the screen, on that stage, on that window, is where I'm going to place that coordinate, 300, 100.
But why here is use final? It is for the...
Yeah, because the size is final. It's a constant. We're not going to change.
Three of them, right?
Yeah. You could ask the user to type in if you want to, where do you want to place this? But we're not going to do that. This is our application. We're going to place where we want it to place. This is not like a game where the user can place anywhere they want. So that's where it's going to be placed. But do you understand this, what it's doing here now? It's just creating that box where I can show. So finally, I can show. And then once I show, I return that graphical user interface. And then guess what? I can put stuff in it. So for instance, right here, GC now has a stage. I can put look at here, draw. What do I want to draw? For each square, I want to draw in that graphical user, in that box. Draw a square, draw a circle. Okay. You got it? Somewhat? We're going to talk about this. I don't want you to just, you got to understand this right now. But we are going to talk more about this when we hit chapter 12. Sounds good?
Gotcha, yeah.
We're almost there. We're going to understand a little bit more.
All right.
Right now, I know it's kind of like, okay, where did that come from? How did that go? How did that happen, you know?
Yeah, it's kind of like when we first started, Java is the like half title, half file. We don't need to learn that, just did it, right?
Well, the point of this example here was for you to understand how inheritance works and how polymorphism works. And that was the idea here for this example.
Mm-hmm.
But understanding really how because as you can see, they assume we went over chapter 4, and we really didn't go over chapter 4 because I left that for later.
Okay.
I mean, we could have done this without the graphics. That's it.
Mm-hmm.
All right, so the last thing we talked about was the chapter, the example 19, and I think that's the one that shows polymorphism, isn't it?
Really?
Yeah, that's the one that shows polymorphism.
Oh yeah. So
Remember,
before we talk about
inheritance.
programming assignment, we say that we cover this one, 19.
That's correct. That's correct. We covered this last. That was this was called last. This was what we went over last.
Before we
went over the assignment, yes, I said, let's stop here and go over the assignment. And then I told you guys to read about interfaces, right? Interfaces, anybody? Anybody? Interfaces? Y'all read the rest of the chapter? You can be honest and say no.
No.
That's fine.
Nobody read it.
Nobody. Oh my goodness. All right, so. I know, huh?
Yeah, you know we are allowed to read it. Lisa, did you?
So you have to add this.
Let me take a look at here, interfaces. What are we gonna do with interfaces? Let me see if the presentation has a better explanation than this, because really the book doesn't show much about it. Let me see my presentation here for chapter 10. So what is an interface? Do y'all know what an interface is?
Interface is like two things connected together, probably.
Definitely, that's true.
Yeah, joining the user with the backend of the thing, right?
Well, yeah, somewhat. For instance, for the extend, right? A class when it extends another class, right? That's inheritance, right? Like what we've been doing with the squares and triangles, they are a shape, right? We have a shape. So we have a shape, and then, or is it a shape? Was it a shape? I don't even remember.
No,
but anyway,
figure.
A figure, that's it. So it's a figure. So when we say circle and square, what do we say? Extends figure, right? Extends figure, right? For both square and circle, they extend. Well, with the interface, they implement, so it's not extends, we implement an interface. And again, an interface has generic methods. So for instance, right here, a class can inherit directly from only one class, right? So like the circle and the square can only extend figure, right? You got that? Can only inherit from figure. So,
so it extends equal to interface?
Like,
extend equal to interface?
The markers get taken away. That's great. All right, so go ahead. What are you going to say? No, we're going to get your interface. Oh, I found it.
Is inheritance equal to interface?
No, two different things. Don't. I'm just trying to give you a background here. So you have here figure, right? Figure. That, and then I have a circle here, right? And a square. Why did I write square like that? Is A, right? Isn't that what we did? This is extend, so that means square extends. I'm just giving you a comparison here of inheritance, okay? Extends figure, circle extends figure, okay? Because what happens? Circle is a figure, square is a figure, so I extends. Both of them I extend, right? Now, those two classes here, square and circle, can only inherit, have one parent. Figure is my only parent.
Okay.
That's what I'm trying to say, just one. Now, to allow classes to inherit behavior from multiple sources, like let's say, here's another class, which we make that as an interface. Interface, okay? I can kind of inherit it from this here, but I don't extend, I implement. We're gonna take a look at example here. I implement methods that are in this interface over here. So I'm gonna talk about implement. So an interface will typically specify behavior that a class will implement. Meaning every class that implements an interface, okay, will create those methods. So let's take a look at here what else we have to say. Now, interface members can be any of the following. It can be a class, it can be a constant, it has to be public, all the methods have to be public, but you can also have private, and you can also have other interfaces. It can have public methods, public default, and abstract and static methods, and private methods. The syntax of an interface is, instead of saying class, we're gonna say interface. So we're gonna say public, interface, and whatever that name is. And then you have the body of the interface. It's very similar to creating a class, but this time we don't use the word class, we use the word interface. All right? All interfaces are abstract. That means I cannot create an interface object. I can't. I cannot, let's say the figure is an interface, which is not in this example. We're gonna have another example. But I could never say new figure. You cannot do that if it is an interface, okay? You cannot do that if it's an interface. You cannot instantiate an object of an interface. You can't, okay? The abstract keyword, however, can be omitted in the interface definition. You don't have to put an abstract there because they're really not abstract. The interface fields can be public, static, and final, but you can omit those keywords or if you don't specify them. And when you define a field in an interface, you must assign a value to the field. You must have an initial value for that field.
What is field?
Field is like age, social security number, name. That's a field. Remember the properties?
Attributes?
Attributes, fields, yeah.
Oh, they are sitting? All right.
Yeah, so let's take a look at here an interface here. Here's an interface, string handler. Is that an interface? Look at here an example right there. It's in your book. This example is folder example 10, 21, 22, 23, 24, and 25. Let's take a look at this. Look at this interface. Let's look at line by line, okay? So this is an interface. Notice we didn't say class, we said interface, right? The name of my interface, string handler.
What is string handler?
Well, whatever name you want to call. I could call Shui. I could call Sylvia. Remember, the name of your interface can be anything you want, just like in a class. All right, so here are the methods that I have to implement. But I'm not implementing, I'm just having a prototype. So those are abstract methods that this interface has, that whoever implements this interface has to do this here, okay? Has to implement this.
So this prototype?
Somewhat. If you want to use the C++ language, yes, that's kind of like a prototype. But you don't implement here. You implement in your class that implements this interface.
Oh. But implement.
Now, this class, I take it back, this interface
You
has,
take it back? Why you take it
I
back?
know, huh? This interface You guys okay over there? What are y'all doing?
John,
Okay, you still trying to work on that? That was a homework. Y'all didn't get it?
I got it finally, I think.
You got it? How about you?
Done the right way this time.
Still working?
So, right.
Alright, so this interface has three methods that whatever class implements this interface has to implement those methods, okay? They have to write those methods. I'm not writing for you. I'm just having a placeholder here so that if you want to implement me, you're going to have to implement my methods, okay? But I do have a default method here called parse. And all I'm doing is parsing my string. But how do I pass the string? How do I parse the string? Well, first, I'm parsing to check to see if it's a digit. And if it is, I need to process that digit. Again, I don't have that method. You're going to have to write that method, okay? If it's a letter, I'm going to call the method process letter. If it is anything else other than a digit or a letter, I am going to process others. So those methods, as you can see, they have not been implemented. That's it for my interface. Okay? Is it processing?
It's very similar to superclass.
So, very similar, but we're not implementing this here. Whoever extends this is going to have to implement that. Now, why would you want to use interface?
Why?
Interface is made mostly to provide specification for performing common tasks. For instance, if you have a string and you want to process that string, think about the things you can do on a string. Those are three things you can do using parsing a string. You can check the characters, what they are, right? And they are also very useful code reusability. Interface. See, I told you guys to go look at this and nobody read that. All right. By default, all interfaces are abstract. Okay? They cannot be instantiated, and I mentioned that already. We're going to take a look at this example here. So here is the string handler interface, right? Are we good here? Are we good? Now, if you don't remember what isDigit is, basically it's just returning true or false if the character is a digit. Y'all got it? That's all it's doing here, is return true or false if the character is a digit, and returns true or false if the character is a letter. But if it's any other character, like a period, exclamation point, question mark, then it's going to be other.
Is digit a decimal number?
Digit would be just a number, not decimal, just a number.
Oh.
Because here's the thing, if you type as a string 14.5, that point is a character. Each one of those is a character. It's not to be considered a floating point number. No, that's a separate story. We're dealing with characters here. We're dealing with strings. All right, y'all ready for an example here for a class that implements this? Y'all ready for this? Open the password security handler.java. Password security handler.java. What? I opened the wrong thing. Hold on. Right there. All right, y'all ready? Now, this is not inheritance, guys. This is actually implementing an interface called string handler. So password security handler, the name of this class, will implement an interface. Remember, we're not doing
Extend.
We are not doing this. We're saying we're going to implement that.
Instead of saying extend, we say implement.
Right. We're going to say implement what? String handler. So this class will say, okay, I have some private members here, private fields, right? Length, digit, one character. Those are my private fields. And here's my constructor. We're familiar with constructor. By default, the length is going to be set to 0. The digit is going to be set to false. And of course, the other character is going to be set to false. Now, what is the first method we have to implement? Process letter, remember? So process letter is what we have to implement. And all we're doing here is saying the length plus plus. Basically, I'm processing one by one. incrementing that length of my string by 1, or whatever the length is. So in that case, its length is equal to 0. Basically, if I check a process letter, basically saying if that character I'm passing here is a what does process letter do? I have a default method. It basically increases the length by 1 if it's a character. And I'm going to increment the length again of that string that I'm passing. I'm going to pass that character also, and I'm going to check if it's a digit, and I'm going to set digit to equal to true. And then, of course, my process order here, what's happening? My process order, I'm going to just increase the length again by 1, and then I'm going to set other character to true if it's not a character or digit. But here's what's happening. Because I'm implementing string handler, I'm automatically calling this method as well, right? I'm automatically calling parse. Parse is being called automatically whenever I am trying to handle the password, whatever this here. It looks like this is a checking for a password, isn't it? Checking to see if your password has digits and, right? It looks like it's checking.
Sometimes it is requirement you to have some letter and some digit.
Right.
And the
letters and digits and characters, and it's counting to make sure you have the right thing. Yeah.
And then one uppercase.
Right. And then of course here, if you have a weak password that's less than 6, if you have the length is greater than 8, and you have digits and other characters.
Oh, yeah.
You set to strong password, right?
Yeah.
Don't you get that when you sign up for something and you type a password, it will give you weak, strong, or medium?
So if you have a uppercase or and lowercase and some digits, some letter, so it will be strong.
Yeah.
If you only number, that will be weak.
That's correct. So take a look at the client now. Open the client for this password security. Oh, I keep clicking on the wrong thing. Look at the client. Why it won't let me open this?
Another one. Yes.
Let me see this.
Next one.
It's the one in yellow.
Right here?
Yeah.
Okay. All right. All right, so let's take a look at this client. What's happening here? All right, so the client, just a regular class, right?
Just regular?
Yeah, just a regular class, and we have the main method right here, because we're going to run a test. This is the test, right? Client is normally a test class. So, okay, so we have here the main class here that is going to ask you to enter password, right? Mm-hmm. And guess what happens? Like I told you, the parse, it is going to be handled automatically here. It's going to be handled. So because I'm implementing the password security handler right here, because I'm implementing string handler, I can call the parse function right here, this function, right? To handle my password. So meaning, hey, for this object, password security handler, PSH, for this guy, parse the password.
PSH is object.
It's an object of password security handler. It's an object of this guy right here, of this class.
Oh, we can call.
You can only have objects of classes, not objects of interface. So just remember that. So because this is a class, I can create an object of password security handler.
Password security handler is class.
It is, that's right, which implement the
string
interface string handler, which contains generic methods that are going to be used for handling any kind of password.
So which means if we create another class that using password, we can also implement string handler, right? And to use.
Right, we can say because we implement, that's right, because password security handler implements that interface, I can say, okay, then parse my password. So what's gonna happen? It's gonna call parse. When it come here, for each character, it's gonna loop through each character, right?
And then to see
If it is a digit, I'm gonna call process digit. But where's process digit? Is in here. Right here. Process digit, right there. It's gonna do this guy. And then go back in here and say, okay, if it's a letter, then we're gonna process letter. Then where's process letter? I wrote over here. Right there. And then I'm gonna have process order. I call the method process order. Who has those methods here? Well, my class have. My class has those methods. So I know what is what. And then of course in my client, I'm gonna display the password. And then if it's weak or strong or medium.
interface.
Okay, hold on.
What
hold on.
interface can use the method of the class?
Because I'm an object. Look, now interface. Now listen.
No, in the interface, you use the method of the password security handle, right?
All right. So let's take a look at this. Draw a picture here for you.
Oh, okay.
So I have an interface right here. What is it called? String handler? Yeah, string handler. So that's my interface.
Okay.
And what do I have in my interface? I have 3 methods here, right? 1, 2, 3 methods. And I have a default method called parse, right?
Uh-huh.
All right, so this is my string handler, my interface. I have a class over here,
Okay.
password security. Oops, password security. Let me write this. Password security
Uh-huh.
handler. Okay, this one here has some variables. Okay, and what happens? It implements this interface. So I have some variables, and then because I'm implementing this interface, I also have those 3 methods here, right? Method 1, method 2, and method 3. What does it mean implement? Well, because I have 3 methods here, and I wanna use this parse, I wanna use this handler, and I wanna implement here in my class. I need to create those methods here. I have to write them here,
Body, right?
right?
Body bar. So which one is parent? Which one is bigger?
There's no parent, no relationship,
parent.
no. This is not inheritance.
Okay.
This is implementation. This is no inheritance.
Okay.
All right, so then I have a client here. A client allows you to enter the password. You enter the password. Well, I have another method here, right, that checks to see if it's strong, medium, or weak, right?
Mm-hmm.
You let me define if it's strong, medium, or weak. So I enter a password, and what does it do? I call the parse method.
Mm-hmm.
On that object, not on password, right? I create an object. The object I created here was PSH, which is a password handler. I create an object. There's no inheritance here yet. This is just testing. This is just a test. There's no inheritance going on here. Mm-hmm. This is not a child of this, and this is not a child. No inheritance, just implementation.
But why we don't combine this interface and class in one folder?
Don't need to, because I can use this again for something else later.
Oh, okay.
So that's what the interface is about. Interface allows you to reuse that. If I combine this, then it's too specific here. I can't reuse it.
Mm.
So interface allow for reusability.
Oh, okay.
What if I want to process, instead of processing string, passwords, what if I want to process a text and count how many strings I have, how many characters, how many digits, and how many,
What?
special characters, right? Point, decimal, point, exclamation point, right? Okay, let's write a class. Let's write a class that implements this, but we're gonna count how many characters we have. Let's do that. Do you wanna do that?
So we still need to use these three guys, right? We also need the same name in the class.
All we're doing is counting them, yeah. All we're doing is counting them.
Okay.
Like whatever class we write,
We also need three methods in that class.
yeah, we're gonna have three methods, but we are not worried about, security level here. We worry about getting the number of characters we have.
Okay.
We need a function that will check how many characters, how many characters, how many digits, and how many non-characters we have. How would you can implement it, you can create another class that uses this, because that's how it's doing.
Mm-hmm. Okay.
Does it make sense?
Yeah.
Okay, so that's why we can't combine the two. Like you said, why don't we combine the two? Because we want to be able to use this to process any letter, any digit, any other special character, regardless if it's a password, if it's a username. Mm-hmm. Look, this here is handling passwords. Mm-hmm. But what if we want to handle username? Do you want to allow special characters in a username? I mean, do you want it? I mean, some people might come with weird usernames, but still, do we want to allow usernames?
Oh,
to
yeah.
have
Like Java title name, you cannot use
No spaces.
No
special
spaces.
character. Yeah.
Yeah, we don't want spaces in there. But how about if we are processing a paragraph? If we have a paragraph and we want to count how many characters we have, how many of them are ABCs, right? How many of them are digits? How many of them are comma, period, exclamation point, and so on?
Okay.
We can use this interface because we already have something there for us to do.
But we also need to use these three methods, right? Every time.
Every time we implement this interface, we have to
We
implement
have to
those.
use these three methods.
That's correct.
Can we add one more? Yeah.
You could add another method,
So
or you can create your own other class.
String method is the one we add, right? In
You
this
could add
particular
the
class.
string. Yeah, we don't need to though, but yeah, you could add any other method you want here. But for this purpose, we don't need anything. All right, y'all ready for the next interface?
Did you finish client?
No, yeah, we finished the client. We just checked. Remember, the client's pretty small. All I'm doing is parsing the password
Okay.
and displaying the password. Run this. Run and tell me what happens
Yeah,
when you run this. When you run this and you type a password, I don't know, sunshine. That's a bad password. 1, 2, 3. Look, sunshine 1, 2, 3. Press enter. Security is medium.
Is there
How about a
password?
weak one? A weak one would be what?
So all digits. Like
1, 2, 3, 4, 5, 6.
Yeah.
It's still saying medium though.
Have you ever used this?
This system is broken. That should say weak, right? What you guys think? If it's less than 6 digits, mine is 6. It should say weak. Why is it saying medium? Oh, 6 is less than, okay.
Is it 1, 2, 3, 4, 5? Is the real one?
Okay, so the length is less than 6. I would say less than 6, less or equal 6. And I would say also, and no digits and no other characters, or maybe, well, that would be complicated because.
My actual password is strong.
Yes, you typed it in? Okay.
I can't show you though, because
That's all right. I don't want to see it. It's okay. Keep it to yourself. You know, like, no, sometimes students come and ask for help and then they type their password. I'm like, I don't want to see because I don't want to be the one blamed to, oh, she will look at my password. Now she knows. All right. But you know what? It's not hard to get anybody's, I don't need nobody's password, but it's not hard here in this classroom to know other people's business because a lot of students don't log out.
Me and Andrew were always in the business.
You what? You what? You and Andrew what?
We basically share like everything.
Oh gosh.
Yeah, you have covered.
Y'all brothers from another life.
Yeah, maybe.
Look at this next.
Not married, though.
Look at this next interface.
You're going to marry?
No, not. Oh my god.
Well, look at this next interface, guys. What do you think here? What's happening here?
Let me read. It's checking if it's valid. I guess. It looks pretty basic. TBH.
Quieter. What? Green white. What does it mean?
Well, this is an interface, right? Basically, do you see functional interface here? This is just for functionality purpose. And it's, as you can see, it's an informative annotation type used to indicate that an interface type declaration is intended to be a functional interface as defined by the Java language specification. A functional interface has exactly one abstract method. Since default methods have an implementation, they are not abstract. If an interface declares an abstract method overriding one of the public methods of the Java language object, that also does not count toward the interface's abstract. So method count since abstract method count since an implementation of the interface will, y'all read those things, have an implementation from the Java or elsewhere. So I just moved my mouse here and it told me all of this.
What? Why does it do that sometimes? It's doing it now though.
So this is a functional interface. So let's take a look at here.
We talk about programming assignment?
Not yet, no. If we are going to, I don't know. Hold on, let me finish this. I gotta finish this chapter, guys, today. I gotta finish this today. Hold on.
Finish today? Oh my god.
Okay, so here's the thing. If an interface has only one abstract method to implement, it is called a functional interface, and it can be used with lambda expression. Does that come to your mind, anybody? We're gonna cover later in the textbook, so I don't know which chapter we're gonna cover that, but anytime you have a functional interface, make sure you precede your interface declaration with @functional interface, okay? But guess what's going to happen here? Open the one that says hex string handler Java right here. Open this guy right there. Ooh, what's happening here? Y'all see something that you haven't seen before?
Something you haven't seen before? They have a comma.
It implements string handler and validator.
Implements two interfaces. So with interfaces, you can implement more than one.
Oh. So
not like in ESA inheritance, you can only inherit from one class, but implementation from many. So here's another class we have. And what is the name of this class again? Hex string handler.
And the Y delta. So this is more useful than inheritance.
Oh, absolutely. You can have inheritance. You can have a class that is a child of something that implements another interface. You can have a combination of whatever you need to do.
Oh, so they'll be used for very big projects.
I have another interface here. Let me see. Another interface here called interface is the validator, right? We just saw the validator. So this will implement And also it's going to implement this guy. Implements. So the hex string handler will implement interface validator and string handler. So what are we doing here?
So these cards have both function of these two interfaces.
Right, so what we're doing here, we basically checking to the user to enter a decimal number, a hexadecimal number whenever we check the client. So hold on. We're gonna ask the user to type a hexadecimal number, right?
Mm-hmm.
And then we are going to instantiate, the hexadecimal string handler. So what happens is we are going to parse that string to make sure it's a valid hexadecimal number. So the parse function from my string handler is going to, let's go see down here. The process letter is a little bit different. Do you see here?
Yeah.
Process letter is different because now we are checking to see if it's a valid hex. You see that we are getting the numeric value of C and we are checking to see if it's between 10 and 15 because it is a valid hex. If it is a number between 10 and 16, we gotta multiply that by 16 to get the actual number. And then otherwise, it's not a valid hex because hexadecimal goes from, hexadecimal number is from 0 to 9, correct?
And A to F.
A to F, that's correct. So 0 to 9, A to F. So A to F is your 10 to 15, right?
Mm.
Is from your 10 to 15.
Oh.
Do you know hexadecimal numbers? I think we covered that.
Yeah, that was the first class we.
C++
all
1 or
second-
Java 1? Did we cover one of those
There's
two
JavaScript
classes?
everywhere when you do CSS.
Yeah.
Yeah.
So hexadecimal numbers, that's right. Hexadecimal numbers are numbers from 0 to 9 and A to F. Now, if you want to look at what you can do, open the calculator.
I know. Yeah.
I told you guys that, right?
Uh-huh.
Programmer,
Yeah.
and here's your hex, the
Okay.
A, B, C, D, E, F. So it's from 0 to 9, A through F. Those are your hexadecimal numbers. So what I'm doing here, I want to make sure that character, that number I typed in,
Is between 0 to
exactly.
0 to 9.
Well, I'm processing every single character, right, in my hexadecimal number, and I'm checking to see if I have any number that is between this range. If it is, then I'm gonna go ahead and update that number. The process digit, again, for any digit, it's all right. From 0 to 9, it's all right. I know it's already a hexadecimal number, but I cannot have any character there. Like if I have a dot, exclamation point, space, that hexadecimal value is wrong, all right? So as you can see, I'm reusing the string handler up there, right? Because I just implemented the 3 methods I need to implement from the string handler interface. So I'm reusing those. And then of course I have one function here that I have to implement from the validator to check to see, what do I do here? The validator function is to return true or false if it is a valid index.
Validator, only one
Hexadecimal.
function. Only one function. Is
Yes, the only function is here is to check to see if it's true or false, if it's valid or not.
So and that we implement here, right?
Yeah, we implement here because we say implement validator, yes.
Return, this means it's true, right? Or not?
Yeah, it's going to return true or false. Boolean is true or false. And then basically here I'm going to return that number. If it is valid, I'm going to return the number. Otherwise, I'll return a -1. So open the class, the client. Open the client. Open the client. Okay. So here's the client. So do you see that we are reusing the string handler interface? Y'all see that?
Yeah.
We are reusing it for other things.
Yeah.
So basically, I'm going to ask you to enter hexadecimal number, and I'm going to call the parse function again for my string handler.
To check.
And I'm going to pass that, and then what's going to happen? It's going to come in here, And it's gonna, because this is the class that has the implementation, it's gonna run all those functions here, right? It's gonna run all of those
All
functions.
those?
Yeah, it's gonna run them because it's gonna have to check one by one. Then finally, I call the function
It's
from,
valid.
yeah, is valid if it's true or false. Run that.
If it is true,
Let me enter, ooh, what happened here? Hold on.
you
Oh, yeah, I
select.
know, yeah. So I'm gonna enter a number. I'm gonna enter 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I'm gonna enter that, and it's gonna say, here's the it returns the hexadecimal representation of that number.
Ah, because they have calculation like times
Yes,
16.
it's right there. So if I enter 15, what is 15 hex? It's 21. Well, 15 is
It's
your
1
hexadecimal
5.
number. Take
It's
it
1
back.
5.
This is the number I'm typing is hexadecimal, and this is the decimal representation. So if I enter
A, B, C,
beef,
D, E, F.
beef, I'm gonna enter beef. Guess what it's gonna be?
B will
Beef
be
is gonna be the decimal
11.
representation, 48, 87, 9. So it's returning the decimal representation of the hexadecimal. So here is a program, for those of you guys interested, that converts hexadecimal to decimal.
decimal to decimal. What do you mean?
No, hexadecimal to decimal.
Oh,
Yeah, to
hexadecimal to decimal.
a decimal number. Now, how about polymorphism when used with interfaces? Let's see, this one only implements one thing, okay. Let's open the next folder here, guys. We're done with this folder, we went over everything. Open the next folder. I'm trying to just open folder by folder. And it's gonna be the one that says 10, 26, 27, 28, 29, 30. Last folder. All right, let's take a look at another interface.
What folder it is?
Now, this is totally separate, okay, from what we've been doing. Y'all ready?
Okay.
All right, so we're gonna open the
10, 20
shipping cost interface. That's an interface,
shipping cost.
okay?
How
All
many?
it does, what does the shipping cost do?
It calculates the shipping cost based on the weight.
Calculate the weight.
Well, calculate the shipping cost based on the weight, right?
Yeah.
So
Based on the weight.
yeah, because it's by the weight. Shipping is by the weight.
Oh, so if you buy a
Yeah.
2 apple weight and
Right. So
calculate.
whatever class implements this, is going to have to write this method, right? It's going to write the calculation. Now, remember, I can reuse this for anything. Reusability, that's what we want. Now, let's go to the class. Let's take a look at the first class that implements this. And it's called the flat rate shipping.
Flat rate.
Flat rate shipping. It's basically, there is a flat rate. It's 50 cents, no matter how much, 50 cents times the weight. That's a flat rate. Don't we have that in post office? When you go in there, they have a flat rate. I mean, I think also the stamp is a flat rate fee, if you think about it. But of course, you cannot get a box and put a stamp in there. They're going to send it back to you. But like for letters, it's a stamp. That's it. But if you're mailing a big envelope or boxes, you need to get more stamps. So that's your flat rate. You got that, Shui? It's pretty straightforward, right?
Flat rate means like how much?
It's
per
50
pound,
cents per pound. That's right. That's a flat rate.
Okay.
Okay.
Just English problem.
I don't care how many pounds you have. It's 50 cents per pound.
Okay.
Flat rate. All right. Let's take a look at that standard shipping class now. Let's take a look at standard shipping. Where are we? Right there. Open the standard shipping class. Okay, so we have flat rate. We have the standard shipping. Let me open my flat rate again because it closed. All right, so we have now standard shipping. Now, what is the standard shipping? I also implement the shipping cost. But now it's what? Now we're talking about we ship in a box, right? Because see, you have the height, the weight, I take it back. You have the weight, you have a base charge, and then any extra pound. So now you're shipping something bigger, right? The package. Now they are talking about, by default, it has to weigh 5 pounds, right? The base charge is going to be 2.5, $2.50, and any extra pound above 5 is going to go $1 per pound. You got it? Mm-hmm. Look at the implementation here for this guy, the standard shipping one. Look at what's happening here, right? We're calculating, hey, if the weight that you are telling me is greater than the base weight, then I'm going to return what? The base charge 2.5 plus the weight minus the base weight times any extra pound.
Oh.
Otherwise, if it's up to 5 pounds, it's going to be $2.50. That's it.
Charge.
This is if it's above 5 pounds. This calculation, if it's above 5 pounds. Anything that is 5 pounds or below is going to be this base charge.
Oh my God.
$2.50.
This supermarket is rubber.
Expensive shipping, right?
Yeah, rubber.
How about Express? Express will be more expensive, right? Because Express is quicker. That's the word.
Express.
Again, it's based on the weight. Look at this right now. What's happening here? This is not implementing now. This is not implementing the interface. This is actually inheritance now. Extend standard shipping. Okay, so the standard shipping implements shipping cost.
Oh.
Now, who is a child of standard shipping? Express shipping.
It's
Okay.
child.
Express shipping is going to do the same thing as the standard shipping, except now that I have a surcharge.
Hold on. Quick question. Realistically,
This is messed up.
why wouldn't I just put this in?
Standard shipping?
Yeah.
Because this is express shipping. It's not extended.
More quickly. So
Come
you
on.
need more money. Time is money.
When you go to the post office.
I guess it goes in a separate thing.
Oh,
Right.
Amazon Prime Shopping have 2 days, right? You get more expensive,
Right. Well, because you're a Prime member, you don't
Prime
pay
members.
for
but
that.
you pay
so
Prime member fee.
You pay a fee. Yeah,
Yeah.
that's right. But go to the post office and mail a letter, mail a package, and choose your shipping. Like even if you're going there and you want to mail a birthday card, like the birthday is like 2 days from now and you forgot your mail, you want it to be that quick, arrive on time. So they are not going to say, okay, it's going to be standard shipping plus express shipping. Wait a minute, what the heck?
Yeah, it makes sense.
You wanted separate things, but you could have, like, I understand what you're saying. Maybe you could have a method here.
See, I would have.
Express shipping,
Yes.
you call the calculate shipping, like it's doing here. You call the calculated shipping, pass the weight, and then you add the $10. You could. But I guess the point here is to show that, okay.
Again, it's just like advertising. You can do it.
Yeah, it's basically saying, okay, for my express shipping class, I want to be a child of standard shipping, but I want to add $10 because you want it to be quick.
Yeah.
Oh.
So I want to use whatever you have, whatever your package you're sending with standard shipping, I'm going to add $10 because you want it to be quick. You want it to be express. Okay, but I'm showing here that inheritance can happen with classes that have been implemented by interfaces. All right, next one. Let's take a look at here the shipping calculator. That's our client here. The shipping calculator is our client. All right, let's take a look and see what's happening here.
Yeah, but object. Oh, no, it's not. Yeah, it's object.
Oh, wait a minute.
Scan object.
Shipping cost. Did we do shipping cost? Not the calculator. Let me go back to shipping cost. Oh, we did that already.
We didn't do flat rate.
We did flat rate.
Ferrari.
That's okay. Standard shipping.
We did
Express shipping. Okay, the shipping calculator is right. That's it. We don't have anything else. That's correct. All right. What do we have here?
So you have
As you can
object.
see, we created a shipping cost object, but we did not say new. Remember, shipping cost is on an interface, right? We can create an object, we just cannot instantiate and say new shipping cost. So we created a shipping cost object and we set it equal to no. And then we're gonna ask the user to enter the weight of the item. Because based on the weight, we have some options here for you. We have express shipping, 1 to 2 business day, standard shipping, flat rate. Now, Gray, I think that's why it would be a better idea to separate, because based on the option, we call that class. We can instantiate that class. So if I choose express shipping, I'm going to instantiate an object of express shipping. If it's a standard shipping, I'm going to instantiate an object of standard shipping. If it's flat rate shipping, I'm going to instantiate an object of shipping cost. Flat rate shipping. Then, of course, any other option is invalid. And then I'm going to check here. If the shipping cost is not equal to no, I'm going to display your shipping cost. Now, here's where polymorphism happened. Y'all see this? Shipping cost dot calculate shipping. It happens in runtime. How do I know which calculate shipping method should I call? How do I know? During running time, when it's running,
Java virtual machine.
Java will know which one to call. Java will know what shipping cost is. Right now, depending on what I enter, I know if I enter 1, shipping cost is going to be express shipping, and Java will know to call that method from express shipping. That's what polymorphism is happening right here. Shipping cost has many forms, right? It can be express shipping, extended shipping, standard shipping, and of course, flat rate shipping. It can have many forms. But when I call calculate shipping, it knows from which form am I going to call to.
Genius.
Genius, you think so?
Yes.
All right. Any questions about this?
It's magic.
This is the last thing we had to cover here for this chapter.
Really?
Yeah, last thing. So now what?
Programming assignment.
Programming assignment, we have a few minutes left.
We
I
have
don't even know where my
20 we have
programming
20
assignment
minutes
is.
Yeah, we never finished the,
Skeleton, right?
Well, I finished the skeleton for you guys, but
oh.
You
we can-
finished?
let me take a look here. I finished the skeleton. I can't do everything. Y'all want me to do everything?
No.
Uh,
I mean, you wouldn't.
Where is I created a chapter 10 assignment right there.
yeah, but
Vehicle.
you didn't fit. You did?
I mean, I had the sets and the getters, and
Could
y'all,
you-
I
could
do
you-
have an abstract class that whoever
Will you
inherit.
Will
is
you
gonna have
upload
to-
this skeleton?
You didn't, and I didn't upload because did we type in class?
No, we never finished.
We did. We
That's
didn't
what I was-
finish.
That's
Probably.
what I was telling you. We didn't finish. But then
Yeah.
you said you finished, so you must have did it after class.
Yeah.
No, this here, I typed this in front of you guys.
No.
I did. Y'all were
Oh.
here when I typed all
I
of this.
found it. I don't have anything for bicycle though. We must have
Yeah.
skipped over that one.
Yeah, we didn't do bicycle because I was debating about
Yeah.
what is bicycle gonna have.
Okay, I didn't remember us finishing what we did.
Oh, wait a minute. I do need to say here, motor vehicle extends vehicle and the bike too. Vehicle. Okay, this is what I did not finish, but I know I typed this. But now we have to implement. See, I have an error saying the type bicycle must implement the inherited abstract method vehicle the horsepower. So I gotta implement this class right here, this method right here. I have to say public int. So I have to implement here the same thing. So I need to say override, right? For the public int, what is it called? Horsepower. And I gotta return the horsepower. How do I calculate horsepower? Is engine volume times liter?
Oh, that's okay.
Times liters.
Isn't engine volume?
Is that right? That doesn't look right. Hold on.
Engine volume is measured in liters, right?
Yeah.
Okay, so hold on. I gotta go back to my.
So that's the same.
Let's see here. the engine volume displacement in liters and okay, the measure of horsepower, the number of liters times the number of wheels. Oh, we need wheels.
Oh, that's right.
So the motor vehicle need another variable for wheels? Do I need another one here for wheels?
I suppose.
And wheels.
Private engine wheels. Wheels.
So let me go back and do here. So it says horsepower, the number of liters times the number of wheels. So it's gonna be an integer, right? The number of liters times wheels. Let me go ahead and create a constructor for this. Motor vehicle. And has a default constructor, and the default constructors, the engine volume is equal to 0. The liters is equal to 0. And the wheels, I'm gonna put a minimum of 2 wheels, right? How about that? Minimum of 2?
Right.
Because you see, for liters and engine volume, the bike doesn't need any of that. So how about the public motor vehicle? That's the overloaded constructor, right? So I'm gonna say this dot engine volume is equal to engine volume. This dot liters equal to liters. This dot wheels is gonna be equal to wheels. Okay, so that's my default constructor. Oh no, wait a minute. The engine volume, I'm gonna go ahead and call. Should I ask the user to type engine volume now, huh?
What about unicycles? I'm just kidding.
Ah,
That's too much.
yeah, let's just stick with 2 wheels minimum. How do you calculate the engine volume? We don't know, do we?
We don't know. Don't do that.
Engine volume displacement in liters. Okay, engine volume and liters are the same, aren't they?
Yeah, they should
It
be.
said it's measured in liters, so yeah.
Okay, so I'm gonna take engine volume out.
Oh, I
We don't need engine volume.
I'm agree.
We just need liters and wheels. That's it.
Okay.
We can have a method that returns the engine volume, right?
Yes.
But the liters, should we have on the set, like, set wheels? Let me do another one here. Set liters, get wheels, get liters. I need to, where's the method that I need to extend here? What was it? We need to get going. What was the method we have to implement here? Public int horsepower.
Man, dude, these Java shortcuts are so
Oh, I already did this up here, didn't I? Hold on, did I implement this twice? Horsepower, I already have it.
We did work
Duh.
on it.
Why I'm doing this again, I don't know. A lot of this stuff I didn't type, guys. As you can tell, I just typed get, and I
right.
pop up get. I typed set, and it brought up set. So be careful, I didn't type a lot of the stuff. That's why it's going fast, and I hear y'all typing. But I hope you already just typed, you know, like when you type in here and you say set, you can pick the method.
Okay.
All right, do we have an owner? What does the owner comes from? Oh, we have owners here, so because we are going to, okay. Oh, we don't need set wheels or get wheels. We don't need any of that. We don't need that. Let me go back. The set wheels and the get wheels, they're already my parent. I don't need to implement again. Or maybe I can, because it will take the super. It's all right. I don't really need it, but okay, I'll leave it there. The only difference here is a motor vehicle has leaders and a bicycle has owners, right? So for the bicycle, all I'm gonna do is say here, all I need in here in the bicycle is public. Wait a minute, I need the wheels for the bicycle. One bicycle is 2 wheels.
Yeah.
But I'm gonna put the horsepower here. I'm gonna return wheels. Is times wheels times the liter? Horsepower? The only thing a bike has is wheels. Public, bicycle. I need to get ready for the next class, guys. Public, bicycle, and I'm gonna just have a default. I'm not gonna have a default constructor. I need to pass the number of wheels, so I'm not gonna default constructor. It's gonna be 2. Always a bicycle. Bicycle means 2 wheels, right? So I don't even need to do this. Default constructor. Not gonna do that. I'm gonna just say wheels is equal to 2. Yeah, because if a bicycle has 3 wheels, that's a tricycle. 4 wheels is a 4-wheeler. So bicycle is 2, and that's it. It returns the number of wheels, 2 horsepower because of the number of wheels. I would say that's it for the bicycle. Let me look at my motor vehicle. What am I doing here? Now this one here for the motor vehicle, I can have 4 wheels, but I start off with 2, but I can have 4. Oh, I don't need the engine volume either here, so hold on. I can have a function that returns the engine volume. Well, it's the liters. All right, this is it for all those here. Horsepower, liters times wheels, and then the vehicle. Now you can write I gotta finish this, but y'all gotta write the client now.
Yeah, but
I have a quick question. Maybe I could save it for another time.
Okay, we can do Wednesday. Wednesday morning, we're gonna have the quiz for this chapter, and then right after the quiz, I can kind of answer any more questions you might have, and we can kind of tweak this if we have to.
Yeah.
all right. Could you?
Before we start the next chapter 11.
Can you open all folder? I want to see all scars that you have, and then you just.
Okay, the vehicle
Yeah.
is the skeleton.
Whole thing, and then I'll just pause to watch the recording.
Oh, it's on the recording. Okay, so this is your vehicle. Okay, so this is your
just quick
vehicle.
review all whole thing.
Okay, so right there, you can just slow down
Okay.
or pause.
And then next
Motor
one.
vehicle from the top
Okay.
down.
Okay.
Okay, and then your
Bicycle.
bicycle. That's it.
What do you have in client?
Client, I have that.
Nothing. Okay.
All right, sounds good.
So what function do we need to write for that?
In the main.
Yeah, what do we need to
You asked
have?
the user to enter. What do you have? I mean, what's your name? Because remember, the vehicle has an owner too. Owner is a string. Hey, what's your name? What kind of vehicle do you have? Or how many wheels? You know, like you gotta use your classes. You gotta, if you say you have a motor vehicle, okay, how many liters do you have in yours? And how many wheels? And then you're gonna say, okay, your car has this horsepower. Basically, you wanna call those methods and test them
And then
to see if they work.
Okay.
All you gotta do is call those methods in the main class. I mean, you're writing the classes, now how are you gonna test them? Well, by testing the methods.
Mm-hmm.
Make sense?
Yeah. See.
Wonderful.